also has a sample size. What is my optimal sample size if I want to be this particular level of confidence? Now, the one thing that you have to remember too is that as you get to be more confident in something, you need to be more exact. Your confidence levels are constantly changing. We kind of use the same basic ones here, although they can vary. But we kind of keep them the basic ones. We also had this thing where we tested this. We haven't really been testing them just because they have to work, but we haven't worked here. But the n times p greater than or equal to 5, n times q greater than or equal to 5, we should have been doing all along. Because n and p have a big to do in this matter. Now, sometimes you're trying to figure out your sample size. How many should I put in my sample? So I always go back to the elections. So say Trump, he's running for the first time ever. And I need to pull a sample of people and see what they feel about Trump. But I have no background on him. No one ever said 30% of the people are going to vote for him. I have no previous information. So when I get to this point, I don't know what my P and my Q are, because I have none. This is the first time he's running, first time I'm ever doing this. I have no P and Q. So if we have no preliminary estimates, we set our P and Q at 0.5, 0.5, 50%. Well, let's assume 50% vote for him, 50% don't vote for him. First time through, that's what we assume. Once we establish a routine, a pattern, and we know who's going to vote for him, now we can change our P and Q. We found out 34% of the people will vote for him. Now we can do it again and put P in there as 34. But initially, I have no preliminary values. He never ran before. I have no background information on him. So when we do that, we say stay the middle of the road. Go 50-50. That's your 0.5, 0.5. So first time through, we may need to put a P and Q of 0.5. So we take this formula, which I will give you, which comes from your E formula. It comes from this. And you don't have to worry about it. I will give this to you. It just is played around a little bit here. So if we divide this by ZC, and then we square both sides, and then we bring it all over, it all ends up looking like that. So I will give you this formula as well. So first time through, we're going to put in our P, we're going to put in our Q. We have none. Then we're going to take this, and we're going to multiply by your ZC, or your confidence interval. And did I not have a confidence interval here? So say our confidence interval, let's just make one up. Say our confidence interval is 0.90, and our margin of error is 2. Oh, it can't be. 2%. So within 2%. So this is going to be 0.02. Remember, these are proportions. So now, if I plug this in, and I say my ZC for 90, I do my inverse norm, 1 minus 0.90 divided by 2, I get 1.645, divided by my margin of error, and I square it. And what did we always have to do to your sample size? Round which way? Round up. I'm always going to be rounding up. Okay? So now, if I stick this in my calculator, let me pull my calculator. Again, just be careful of your parentheses in your calculator. If I put this in, 0.5 times 0.5, this part I can do, not a problem. Now, this does not get squared. This guy gets squared. So this guy, you need a parentheses around. And the reason I'm doing this is because that's where you guys are making your mistakes. Not putting the parentheses in the right spots. 1.645 divided by 0.02, the parentheses, and square it. Whoops. Square it. Where's my square? You know what I'm saying here. I honestly don't know what happened here. Let's see if that worked. No, I think it pulled something else down. It definitely pulled something else down here. I don't know what happened here. Okay, that should work. All right, whatever. We'll do another one. It came out to be what? Thank you. So what do we do with our sample size? Always round up. Many of you guys lost another 2 points on that. Because you're not rounding. 2 points. I'm hitting you with this. You can't possibly have partial people. And if you knock this down, you never even hit 0.26. So I'm hitting you hard on that one. And as many times as I say it, you guys are still not rounding. So we'll work a problem or two out with this. Again, I will give you the formula for this. So let's do one that probably makes sense. Oh, so they like my political one. You are running, really, because that's the one that probably makes the most sense. You are running a political campaign and you wish to estimate within 95% confidence the proportion of registered voters who will vote for your candidate. You need to know this, and it's important. You're running this campaign election, this election campaign. Your estimate must be accurate within. See the word within? Within tells me what? What margin of error. Within means to the left, to the right of it. There's my wiggle room. There's my margin of error. So I've got my margin of error of 3%. How do I write this as a decimal? 0.03. Find the minimum sample size needed. If first, no preliminary estimate is there. First time I'm ever running this guy. I'm running this campaign. First time I'm ever doing this. I know no background on it. I don't know who's going to vote for him. So I estimate first. I say P, 50-50. Q, we'll do 50-50. I got a 50% chance. Half and half. Half the people should vote for him, half should not. So that's usually a very different estimate than your actual one. Now, obviously, if it's this far apart, if they're closer together, you'll see that they're a little bit closer. So first time through, we're going to do our P times our Q. Then we're going to put this in here and do our 95. What is our ZC for 95? Anybody remember? Good. So we kind of use the same ones to kind of get used to the same ones. And if not, you do inverse norm, because we're z-scores, 1 minus 0.95 divided by 2. You take the positive. If you took the negative and put the negative in here, no harm done. You're squaring it anyway. But try to just keep it positive. It looks better. People would say, why do you have a negative number here? 1.96 divided by 0.03. That's your margin of error. So if you put this in your calculator, you're going to get this. So how many do I need in my sample space? Thank you. I need 1,068 people in my sample space. I can't have 1,067.11 people. I can't get a 0.11 person. If I drop it down with my rules of rounding, that normally would say drop it down, I never hit that 0.11. I never hit my minimum number. So in this one, you always have to round up. Now, second time around, I do have an estimate. P is 0.31. Now I'm running this, I'm doing this again. But I realized from the first time I did this, that now 31% of the people in the population like my president, my candidate. So now I have a good estimate to go by. So what's my Q? 0.69. I'm going to redo this with these two. The only thing that's going to change is this guy right here. The rest is going to stay the same. So what do you think is going to happen? It's going to increase, let's say. So throw this in your calc. Don't forget, that's the only part that gets squared. Don't square this result over here. Don't square this product. Some of you had trouble. I gave you the formula. You didn't even write the formula down right. When I know my estimates, I can be a little bit closer on my sample size. I can define it a little bit more. Because now I do have an estimate. If I multiply this together, this is like 0.25. If I multiply this together, even if I say 70, this is like 0.21. So I'm multiplying by a smaller number here. Okay? The closer I get to 0.5, then I'll get closer to that number. But otherwise, I should be a little bit more exact because now I have something to work from. Okay. This is the only thing that's changing. This piece right here. Because that other part stays the same. Okay? That's the only part that's different in here. We run a sample size, but sometimes we don't really know an estimate. Again, when you're looking for your margin of error, make sure you find the word within. Okay? Also, it's going to give you a percent. We're working proportions. We're working decimals. So, there's your decimal value. Olivia, no phone while we're working here. Come on, guys. I want to see your phones out. All right, so you guys try it 4. We're doing this in try it 4. I'm going to come around and see that you're working. I never recorded this.
We recorded it on the top.
Okay. Yes.
Why is it that you can put the 2.5s, like 0.5?
Why? Because sometimes you don't have any information before. Like I never tested my population. I never, you're estimating who have had a test. I never did this information before. I don't know what the percentage was. I need to have a percentage of the people that had the test, the percentage that didn't have the test. So if I never ran this before, I have no preliminary estimate. So I estimated middle of the road, 50%, 50%. So I come up with an estimate. Now, second time around, maybe next month I do this again, or next year I do this again. I have previous results, a previous study, because I did the study now. So now when I redo this study again, which you should do more than once, right? You should always run your samples. You should run more samples and more studies. So I have preliminary results. So now all I have to do is replace my preliminary results. I shouldn't need as many. This is like middle of the road. Middle of the road. Give me the most people. I'm middle of the road. I'll get a better representation of my population, hopefully. The reason we find sample size is because we don't know like how many people to put in our sample. But generally, the more doesn't always mean the better representation. It should mean it better represents your population, but doesn't always mean you want to keep building your numbers so high. It's costly. It's time consuming. You have to have that optimum point that you need. Like what I told you from the beginning, this part is a field in itself. Researching how to find your samples, even though we briefly hit it, and every sample we do is random, and there's certain ways that we can sample people, this is like a whole field of study. Because you're going to spend a lot of money on this area. So if you want to get as many people as possible, it's going to be very costly, very time consuming. But you still have to have an equal representation of your population. So if you can fine tune your numbers even just a little bit, it probably saves you time and money. Questions on this at all? And that was a good question, because why do we bother doing this? Sometimes we just don't have previous information. And when you do an experiment in science and you're testing something, don't you retest it to make sure that your values were good? What if you used a different sample of this? Maybe that sample was tainted a little bit. I don't know. So I'm going to run this again and again. And over time, that's how we find things to be over, like we do this over time. And then we can prove this. Someone just doesn't come up and give a flat out statement and say, well, I tried this once and this is what happened to us. So I think this is theory. They run this multiple times. Okay? So I'm going to give you guys a little book assignment. I'll write it down. And you have today and like let's do most of tomorrow. I don't need you to take this home. Okay? Here's your assignment. I want to see everybody working on it. I give you class time to do this.